Contamination causes a high number of failures, and the three main contaminants found in a refrigeration system are moisture, debris, and non-condensable gases. Moisture is one of the main contaminants in refrigeration, and technicians have to follow many procedures to keep it out of the system. It is constantly trying to find its way into the system because modern refrigeration oils and refrigerants are hygroscopic, meaning they have a tendency to absorb water out of the air. Moisture combines with oil to create organic solids and mild acids. It also combines with refrigerant to create stronger hydrochloric acid. This is the acid that can do serious damage to a system. Moisture can freeze in the system's metering device, shutting down the system, as well as in braze joints, where expansion can crack the joint. The moisture can come from improper evacuation during the vacuum process, or not purging air out of service hoses. Tube plugs should only be pulled right before hooking up tubing for brazing. Any residual moisture needs to be trapped by a properly sized dryer. Here we see 3 oil samples, with one containing fresh, unused refrigeration oil. The middle sample is the typical color after coming out of a system and perfectly acceptable. The third dark sample indicates the presence of moisture, and a cleanup procedure is in order involving an oil change, a flushing solvent for the tubing and coils, and a deep vacuum. Moisture can also cause the oil to carbonize. This degrades the oil, reducing its ability to lubricate, cool, and prevent corrosion. Here we see a carbonized valve plate. Deposits from overheated carbonized oil have built up in the hot high pressure area of the valve. This will cause system inefficiency from poor valve sealing and eventually lead to a broken reed valve or a compressor that can no longer achieve enough capacity to maintain system temperatures. Here are more examples of how carbonized oil and corrosion can be deposited on an overheated cylinder head. We also have an example of copper plating of a crankshaft journal. This happens when acid is formed in the system and attacks the metals inside. These metal particles will travel through the system and are attracted to the hot, high-pressure bearings and journals and will cause them to quickly fail. Moisture is removed with a vacuum pump, which lowers the pressure in the system to the point that water is boiled or evaporated. The pump can now easily remove this water vapor. Vacuum level is measured in microns, so we need an electronic micron gauge to verify proper vacuum. We need to achieve 500 microns or less to be sure that the water is vaporized and effectively removed. A new correctly sized filter dryer should always be installed anytime the system is opened for service. Once water has entered a system and acid is formed, it will quickly lead to serious damage. Winding insulation and metals are attacked, causing contamination throughout the system and will cause compressor failure in a short time. If not properly removed, these contaminants can cause a subsequent failure in a matter of hours. Acid test kits and sight glasses work well for identifying a system contaminated with moisture and acid. Once we identify acid in a system, we need to follow a cleanup procedure involving a system solvent flush, followed by a dry nitrogen purge. These solvents are readily available from a refrigeration wholesaler, and severe burnouts require this flush to properly remove contaminants. An oversized liquid line and suction line filter dryer should be used as well. Pressure or temperature drops should be checked across the dryers and changed as needed until the cleanup is complete. Pressure drops should not exceed 2 to 3 psi, and it is recommended to remove the suction line filter once cleanup is complete. Excessive pressure drop in the suction line will cause compression ratios to rise and capacity to drop, leading to an increased load on the compressor and possible overheating. Please click on the next link in the series to continue the course.